Thanks for choosing my talk. That's my general joke for every single track conference. Today I will be talking about the functional foundations of CQRS and event-sourced applications. And so a little bit of who I am. So my name is Renato Cavalcanti. I'm author of CQRS, which is a library for building CQRS applications using Scala. I'm a co-founder of StrongTyped. We are a small consulting company in Belgium, and we give mainly consultancy in Scala and DDD, CQRS, and related technologies. And I'm also the founder of the Belgian Scala user group. The motivation for this talk is actually when I was building CQRS, I was trying to find, okay, what are the main functions that I need to have so I can build some abstractions around that. So I think it's fairly easy to identify them. So there are no complication on that, but I found a challenge to promote that idea. Whenever I talk about CQRS, I realized that because it's a quite different way of building an application, and I realized that people have questions that sometimes shows that they are not yet grabbing the real sense of that. So that's the main motivation of this talk, actually. And I will concentrate on the command side part of CQRS applications, okay? So no query side, because I think it's the most important one, the most interesting one for this kind of talk as well. And I like to define an aggregate as an aggregate aggregates its best. And I will explain more in detail what is that, and then I will talk about how to handle effects, I/O, error handling, and so on. So CQRS. Once I was giving a talk, and I talked about CQRS the whole time, and at the end of the talk, someone asked me, what is CQRS? Because I didn't explain what is the acronym. So Command Query Responsibility Segregation, that's what it stands for. And the principle is instead of having one model, you have two models. One model is the first one is the command side or the write side, the write model, and the query side. So the command side receives, you have a model that is the right side, it receives commands and emit events. And those events are used to update that model, but are also used in on the read side to generate all kind of views or send to other systems and so on. And it's also, there is some mixed, when people talk about CQRS and event sourcing. Event sourcing and CQRS, they are unrelated, but they are very often used together. And event sourcing is when we start to store those events. You can do event sourcing without doing CQRS, and you can do CQRS without doing event sourcing. But I do really think that they match very well together, and it's the best way of doing that, actually. So, but today we will not talk about the query side, we will only concentrate on the command side, okay? So, as I was saying, we define commands, and then we have commands and event handlers, and we have the aggregate. I will come back to what is exactly an aggregate. And the command handler receives commands, and they may emit events. Not necessarily. They can decide to return an error or to simply return nothing, or just return, like, for instance, if you have an option of event, you can return a none. And the event handler, they always receive an event and they update the aggregate. So the first thing to understand is that, we have those two basic functions. So from an aggregate, having an aggregate, I can have a function that receives a command and emits events. And I have another one that, given an aggregate, receive an event and give me an updated version of an aggregate. And having those two functions, I can derive that third one, which is, given an aggregate, I can send a command to it, and I will get an updated version of that aggregate and the events that were emitted. That third function is just a derivation of the first two functions. But as I was saying, a command handler, which is our first function here, they may not emit an event. It's not, they can fail, or they can return a none. So what we'll do here is we'll say that it returns a f, which is not yet defined. It can be a future, it can be a try, it can be an option, it can be many other types. It can be identity, which is actually, I will show later how to do that, but it's just a small construct to have a f that actually is not really wrapping anything. It's just not wrapping the type. So if I define my command handler as being aggregate command and f of events, then I have a type that I can use to express error conditions or to express the fact that I'm not emitting an event and so on. But in the beginning, I don't have an aggregate. So when you start your system, you don't have it. So we have to send the first command that will emit the first event, or the first series of events that will build your aggregate. So actually what we have is a state. I'm creating here, it's not a state monad. I'm creating here just a type alias state that is an option of an aggregate. So at some point, at start, I have none. So I start with a state that can be none. I will send a command that will be validated, and if it's a valid one, think about a constructor, the invariance of a constructor. If it's a valid one, it will emit the first event. And we call it, I like to call it, the seed command or the seed event, because they really create the aggregate at that point. From that point in time, my state will be a sum aggregate, to which I will also send commands, and I will continue going like that. So now my function is, now I start with aggregate command events, and now I have a state, an optional aggregate, a command, and some return type that can express a computation. And of course, the derived functions the third function, the derived one, is also impacted by those changes. The thing is, and what is an aggregate? So it's a term that comes from the DDD, the domain-driven design, which actually it's about having a group of objects. It can be only one, or some objects that together they make a whole and define a consistency boundary. That's the concept in DDD. In CQRS applications, the aggregate is used as your right model. On the right model, you have your consistency boundary is where you have to validate things and decide which event you send next. So, but if you think about that, and that is something that I realized after some while, after trying to explain aggregates to many times, is that an aggregate is like an accumulator. So if we have a history of my events, that's why I changed my type there. Now I have a type history, all my events since the seed event, since my first event. So I can have in my event handler, I can fold left on that, and I can reconstruct my aggregate. I'll give an example that is very simple model. Imagine that we model a natural number. So it has to be a positive integer. And I have commands like add, subtract, multiply, and divide that will emit events like added, subtracted, divided, multiplied. If I have thousands of those events, how can I, by looking to the events, add 2, subtract 1, multiply by 3, and so on and so on. How can I look to it and decide if my next command will be valid or not? I have to execute it. I have to fold left on them. That aggregate will then it's actually the data structure where you flatten all my events to aggregate there so I can reason about that. So imagine I have 1,000 of events like that. Only after I build my natural number back, I can decide if a command like divide by 3 is a valid one or not. If it's 1,000, if my natural number is 1,000, I cannot divide by 3, assuming that I don't want to lose precision. I don't want to divide it by 3, but I may divide by 5. So such a command will have to return a try or some type that will say, no, I reject that one. So the aggregate, it's useful for that actually. But of course, here's a very simple example, natural number. But you can imagine, and we all here build applications where our domain are a little bit more complex than a natural number. So whenever I have a history that is empty, and I fold left, obviously I have a non-aggregate because I don't have a history. And whenever I have a history that is non-empty, I will get some aggregate. And so if we think about the events, my events as a history, I can say that given my history, I can always build my state because I have that event handler, which is that function here that goes from some state, none at beginning, to some state, which is the accumulation of all my history. And because then I can say that I have this function as well, backed by this one behind it, and fold left, of course. And from here I can say now that my command handler is, from a history, I can build a state that will receive, which is my current state now, that will receive a command and eventually produce some events, new events. Which turns out to be that given my current history, I can send a command and I can build a new history eventually, or I can reject the command. And of course, that last function here, it's not the one that we want to use to build applications. It's more the more generic abstraction that we need, but it's not practical. We don't want that. Very often, your aggregate has a couple of events, but I have a system, for instance, where we have 500,000 events for one single aggregate. Well, I don't want to read 500,000 events from memory and add some new events and persist back that. So, but it's here just as a very generic function that express actually what is the basics of CQRS. And then I go back about the effect. Why I